Oh, sorry about that. Okay. So let's a rough intro. So today we'll be looking at API design, and under API design we have a list of items that we're going to be treating. And first of which is identifying resources. We first of all identify resources, and then we look at the rest, creating routes and handlers, and then all of the rest, versioning, and then last but not the least, we look at PostMan. We try to explore PostMan. Okay, so we were in the okay, so let's view our branches again. Git branch -a. Let's just view all the branches, and then we are currently on the API design branch. As you can see, it's colored green, and the rest of the branches are colored white. So we want to do something on this branch. And I we earlier discussed how to name branches. The CS here means this is my name. C is Christopher, and the S is Sesu, Christopher Sesu /. And then the tag it's a feature. This is actually a feature. It's a new feature we're adding. And then the name of the feature is API design. So that's it. And the first one here, the reason why we named it docs is because it's documentation. It's my branch, CS/docs, and then add documentation. That was what we did. And so that's the reason why we are creating our branches like this, so they can be readable. So it will be in uniform, and then but later on we'll see how to enforce branch names and the rest, how we can enforce uniform coding styles and all of that. Okay, so that's great. And I have some things here prepared for us. I think, yeah, PostMan, identify resources, and the rest. We just have 2 items. So what I will do is I will just push this to just git add, git commit. And this is actually a feature of API design. No, we've not actually done anything, but let's see. Okay, not actually a feature, because we not implemented the feature. We'll just say a refactor, because we've added some things, not really add PostMan and resources MD files, like so. You say git push, and then it's telling us that this is not in our remote listing, so we'll copy it and then paste it and then hit enter. So so this branch is now a remote branch, and we can access it on GitHub. So if we visit GitHub, let's visit GitHub, then GitHub repos. We have KodeCamp 3. And we'll switch to the very branch, which is API design. Go to Express Task Manager, and then source folder, then identify resources MD. Okay, so as you can see, the first thing on our list here is identify. First of all, if we want to design our API, we first of all identify our resources and then create routes and handlers. Well, let's look at exactly what identifying resources is all about. Okay, so we come back here, and then I prepare some notes for us to just go through it briefly, so we can understand what identifying resources are, what it is, and then how we can identify resources and then design our API effectively. And you say here in API design, identifying resources refers to the process of defining and representing the various entities or objects that your API interact with. These resources are fundamental building blocks of your API, and they correspond to the data or objects that your clients can create, retrieve, update, or delete. And then in the context of Express, which is popular NodeJs framework, identify resources involve determining the endpoint and routes that your API will expose to perform operation on these resources. And then we go ahead and say, here are key aspects to identify resources in API design with Express. Resource identification. So identifying what your API will manage or expose as resources. Resources can be things like users, products, orders, articles, etc. Each resource represents a type of data that your API deals with. This is a key point here. Each resource represents a type of data that your API deals with. So RESTful routes. In REST, representational state transfer architecture, each resource is typically associated with a specific CSP method, like get, post, put, patch, delete, and all of that. So, for example, in our case, in our task manager, you have the get tasks, retrieve a list of tasks, the get task ID, which retrieves a specific task by its ID, and then the post, which create a new task, patch, delete, and all of that. Then resource modeling, validation, and data transformation. And we did all of this. Define the structure and attributes of each resource. For instance, the task resource, you might specify attribute like title and then description, as we earlier did. And then validation and then data transformation, handling data validation and transformation for incoming requests. And we did that. Passing request bodies, JSON, and ensuring that the data conforms to expected resource structure, middleware and controllers, pagination and filtering, resource relationships, and then optionally consider versioning your API to handle changes. There is all of this has to do with our API design. So talking about identifying resource, we identified our resources here. Then we should move to our controllers. Okay. In our task manager application, a user can create task, edit, and then delete. So we expose the edit task endpoint, the create task endpoint, and then the get task endpoint. We expose all of these to users with minimal APIs for them to create, edit, and then delete their tasks. But actually, we don't really know what's happening. If I delete my task, what's happening, what kind of database is this task manager using, and all of that. They don't care, and they don't really have to care, because if you're using a task manager, all you need to do is, oh, I have to perform this today. I have these tasks to finish up today. So I'll add them to this list. Then when I'm done, I will delete it. So you don't know where you're storing them, and you don't really need to know. All you need to know is how to delete, create, and then manage your tasks, and then all of that. So if it's not clear to you, we have these notes here. You can always come back and then look at this note to get a clear understanding of what API design in general is, and then identifying resources, what it means in API design, and all of that. So that's that for that. We shouldn't be talking too much. You know how to read and understand. So when you read that, you understand very more than what I've just said. And then create routes and handlers. Creating routes and handlers, we did that initially. The handlers are the controllers, and then the routes. Here are the routes. The task route, the session out route, and then the token out route. So we actually organize our API in a very fancy way that can serve our purpose, but then that's not all. There are some things we're missing out, and then we'll talk about that in a minute. And then next on the list, we have our use HTTP methods for operations. Yes, and that's great. We actually used HTTP methods, because if we look at our code here, when we want to send this response, we are using these HTTP methods, and all of that, HTTP code and all of that. The 200 for success, and then if a user is sending in a request, a delete request, what we are expecting is the verb delete. So when they send with the verb delete and then with an ID, we know that, oh, they are referring to this and they want to delete a task. So we handle that successfully. And after deleting the task, we send back a response with a status code of OK, and then with some message and all of that. Okay, so all those have been taken care of. But sometimes if we don't know all this, we just go around building applications without really knowing what we're doing. And let's assume we are using another API for this. You know that this very API we built, we can build another API on top of this one, where we can actually call our API from production and then build another server on top of this one, like build a different server. Then instead of doing all of this, reading direct from our database, and then from here, after getting this ID and the user ID, what we will do is we will send a request. We call fetch, and then after calling fetch, we'll pass in our, let's say, HTTPS / let's say KCTM/tasks, and then we pass in our ID and all of that to that, so that, and then the payload, the task, the title, and the description. So we build on top of that. So when we're doing this, we specify the method. We say method is let's say delete, like so. Or if you want to create, if it's to get tasks, you can actually leave it like that if it's post. But get is the default method. So if you don't want to specify get, you can actually leave it like that. But then post, patch, and all of that are very important. Then we can actually build another server on top of this. That's what I really want you to know. But that's a topic for another day. We can actually expose, after documenting this, we can actually expose it to other users that they can actually build their own servers or build a client side on top of our server. And then the next on the list is versioning. API versioning. Wow. This is great. So what exactly is API versioning? Let's assume we have an application with we designed our API initially, and then we missed out some things. And then we want to improve on those, we want to improve our API by adding where we missed out, adding those functionalities. Let's assume we're creating our tasks without, let's say our API is already in production and people are using it. So we want to actually change the way people create tasks, or we want the task to be a minimum of, the title should be a minimum of 10 characters instead of 5 characters that we earlier specified. And we don't want to directly change because it's already in production and people are using it. Some are using the title of the task is actually 5 characters or 6 characters. So if you go and then change that to 10 characters and then push it to production, definitely their app will break. So we don't want that. So what we are going to do is we'll create another version of that API, and then we can name it. That is not a minor patch. It's actually a brick. It will cause a brick. So we name it a 2.0. That is API will be 2.0.0. But before we go in depth on API version, let's look at semantic versioning. I think that's what they call it. Semantic versioning. Yes, semantic versioning. So giving a version number, major, minor, and then patch increment. The major version when you make incompatible API changes, like the one we've just mentioned, like we want to change it and then we want to say, okay, this time around, we want to change the title to a minimum of 10 characters and not 5 characters any longer. So what we that is a major change. It's version where you make incompatible API changes. This version of this change will be incompatible with the previous version of our API. So what we want to do is we want to release another version of our API so that users can upgrade to this version, or they can stick to the previous version. Or we have the second one here, a minor patch. It's a version when you add functionality in a backward compatible manner. Let's say initially when we, let's say when we create a task and then we send back a task without errors of null. We just send back the task and then only the task object. Then the error object is null. But then we say, okay, since we are sending back errors and then task, if it's an error, we send back error, and if it's a task, we send back task. Let's say if there are tasks, we send back errors of null, and then if there are errors, we send back task of null. So we combine those and then we make a minor change that is backward compatible, so that the client side can upgrade their app and then can support this change without breaking changes. And then the patch here, this is very, very simple. Maybe in your API, when a user is registered, what you send back is user registration successful. And then you send just a message of user registration successful with no error object or anything. So what you want to do is you want to say register success instead of saying user registration successful. So that's actually a minor change. That's a patch. You just send the message, and that is actually a patch. So we have major, minor patch. That's a 0.0.0, or if it's a major, say 2.0. And then if you have an API version of 1.0.0, if you've made a patch, if you have a patch in your API, you change this to 1. That is 1.0.1. Then if it's a minor change, it's 1.1.0. And inside of that minor change, if you have a patch, it becomes 1.1.1. And the introduction, all this semantic versioning specification, Semver, and then all of that. The keyword must not, required, shall not, and all of that. Everything is here. And then let me just copy this, and then I think I should paste it here so that we can get access to this. Okay, so the URL, the Semver organization URL is there. You can visit it and then check things out by yourself. Okay. So in versioning our API, we have to change things. We have to make our folder structure to resemble our API versions, or that would be a kind of a work for us. So let's see how we can just go ahead and then version our API here. And what we're going to be doing is we'll version our API, and then the session auth would be the authentication version 1 of our API. Then the token auth would be the authentication version 2. And then the task endpoint, that would be basically the version 1, because we've not created version 2, and then we leave it like that. But first of all, before we do that, every project needs planning, because if you don't plan, writing code is basically the most simplest thing to do in building any project or any project you're working on. First thing is to take down some notes and then plan your project. Plan it very, very well. That's where system design comes in. I think you can use system design to, okay, what database am I using? what hosting service am I using? Okay, the domain name, what DNS am I using, and all of that. So you have to sit down, and after that, you release an MVP. An MVP is simply a minimum viable product. And it's arguably not a product, it's a mindset. That's what people say. And I actually agree with that. After so much research, I agree it's a mindset, because everything you're doing has to, it should have an MVP, a minimum viable product. Then first of all, release and then improve on top of it. After releasing, you get feedback, you gather feedback in any way you feel you can, and then you improve on top of that. So let's assume our API now, after releasing it, people will give us feedback. Oh, this is that, and they will say, oh, that's correct. And then we improve on top of that. The final stage, you have a standard product that users will interact with and then we use effectively. But first of all, you release a minimum viable product. The mistakes people make is, if you don't have a minimum viable product, there's a high chance, let's say a 0.8 probability, 0.8 probability that you are not going to succeed in your business, that your application or the product you're building, your digital product will not, you will not succeed. So MVP is very, very important. And I suggest you take a step back, maybe after this class, or when when you're less busy, to look at our MVP, which is a minimum viable product. Okay, so it is now time to structure our application. So someone was asking me if they should structure their APIs in this way, something like this, /API/ route. Okay, API/tasks. Okay, that's correct. But then this is where you will understand the importance of this. This public route is not actually an API. When you visit this public route, what you will see is and I actually changed in the name of our app in production. I did something like KCTM. And then Cyclic recommends minimum of 5 characters for a domain. So I wanted to say KodeCamp Task Manager, but then they insisted I should add another character. So I add R, just MR, short for manager, something like that. KCTMI.cyclic.cloud, and then we have this. And then you cannot access any other route. If you go to tasks, you have to be authenticated. So let's see what you've got. Internet server error. It's even, you can't access any other route. /tasks. Okay, like this. And then we have Nginx and Favicon here. Then we have our title, KCTM. And then we have the title also here. Very well. So if you want to version, there are so many ways you can go about versioning your API. But after so many deliberations, I concluded with one way of doing this. You know, if you notice, maybe you don't know how all these work, but let's discuss how they work. If you want to use some APIs that you pay for, there are some APIs you have to pay for before using them, like code execution APIs or other amazing APIs, or all of that. So you see something like X API key, something like this. You see something like X API key, and then you see something like X API version. It's not ideal for you to leave this in as X key, but you can leave this second one as X version, like so. But since it's not ideal to leave this as X key, X API key, and then X API version. I concluded this is the best way to name your API version, as to name your headers when you're sending an API key or API version. So this is actually an API key, but we're not dealing with API keys here because we're not, this is what we call, is it tenant? I've forgotten the official name, but in a case where you are building an application and every user have their own database, like, okay, let's say you're building an application for a supermarket where the user monitors their business, and then everything they're doing is stored in their database and only them can access it. In that case, you have to design your database to support many users, and every user will have his or her particular database, and then their APIs, so that when you send an API key, the API will determine, oh, this key, okay, this is the user. So you redirect the user to the database, and then they'll access the resources in your database and all of that. So in this case, in our headers, we will specify our API version we name it API version, and this is a key pair value. The API version will be something like 1.0.0 or 1.1.1, as we saw earlier in the semantic versioning documentation. Okay, so first thing, we'll have to redesign this. And this is very, very important. You will hardly find this kind of things, but they're very, very important. Most of these YouTube authors, these YouTube creators, most of them are beginners. They start out, learn the basic things, and then come out to teach you without understanding in depth of what they are really doing. So you should be careful while looking out for tutorials and all of that. Okay, so let's structure our application to support this. And then we have to be very careful in structuring this so that our app will not break. So we structure our app in this form, like this. We have our API, and then we have our V1. We have our versions, which can be V1 version 1, version 2, version 3, and so on. And inside of the versions, we have our authentication and tasks. Okay, so let's go ahead and structure this. These errors, we're leaving this in the home, in the project, the source directory. The labs and the Prisma, we're leaving it in the source directory, and then the middleware, we restructure the middleware as well. Okay, and then the routes, we restructure these routes as well. The utils, we don't have anything in this utility folder, but let's just leave it like that for structure, for educational purpose, so that anytime you visit, you see that, oh, you have utility folder, you can write any helper function inside of this, and then reuse it anywhere you want to visit. But first of all, we'll come here and then we create a folder, API, like so. And inside of this API, we create another folder of V1, and then another folder of V2. This is thorough restructuring we're doing right here. Okay, so inside of the V1, let's assume in our version 1, our authentication method was using sessions. So what we will do is we'll come inside of our route. The V1 we have the folder routes, and then it will have another folder of controllers. And then the V2 also we have a folder of routes and a folder of controllers. And all this, the V1 we have middleware, and the V2 we also have middleware, like so. What else do we need? The errors is a general thing that we can use both in V1 and V2. Okay, so now in our route, this is a session out, and then in our v1, in our route, let's first of all start with the controllers. And in the controllers here, we name this, we create a file, and then we name it alt.js. And then we come back, we want to make our session out our version 1 authentication method. So we come to our session out, and then we look at, we copy everything from here, from this session out, and then bring it down to this controllers out of v1 in the controllers, this alt file in the controllers, and then we save it. And then what we will do is all of this, we remove this, remove this database, and then save it. These are third-party modules, so we don't need to, inside of this database, we import it automatically. So importing this automatically, you press Control space on your keyboard, Control space, and then you see how to, this will pop up, and then you hit enter, and then it's imported. You can see this dot, 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 it's very, very ugly. And then later, or in our next class, or in our subsequent class, we see how we can then do away with all this and then structure our project in a very readable manner. And that's that. And then our async wrapper as well, control space, import it. What else do we need? Custom error API, control space, import it. Yes. And what else do we need? I think that's all. Database, async wrapper, custom error API. I think that's all we need here. Yeah. That's all we need here, actually. Okay, so inside of these controllers, we make another file of tasks. Tasks.js. We come down here. The task, or should we say tasks? Or okay, task. Let's rename it to task. And we come in our task. We copy everything. No, it's controllers, not copy everything here. I don't want to rush it so that we understand everything that's going on. Then we paste it in here. And then this, we remove the database and the async wrapper because the paths are not longer correct. Then we import this async wrapper and then the database. And what else? I think that's all. Async wrapper and then the database. Okay, that's clean. I think we're done with the controllers of authentication and tasks. Then we, in the routes, we create new file of alt.js, and then another file of this controller should be outside of the route, not inside. Should be inside of the v1, not inside of the route. And then another file inside of our route, which is a task.js. And then we come down to our task here. This time around the route task, and then copy Command A. If you want to highlight everything on Mac, is Command A, and then on Windows is Control A, Command A, Command C to copy on Mac, and then Control C to copy on Windows, and then Command A. And then we take this to our route in our v1 route task. Is it task? Yes. Route task. And then we paste it in here, like so. We save it, but this time around we will do away with this token out. In fact, everything in here. That is, we do away with this, and then we import it like this. Automatically import it. Let's just leave it let's just leave it like this for now because we have to move the middleware as well. Okay, so now that we have our auths in the route, and then let's move our auths as well, our session auths from the route session auth, Command A, C, and then move it to route auth, then paste it here. Come down here and then do away with all of these session auths, because the route will not match. And then in our middleware V2, we have its own middleware. Okay, we've already created the folder middleware. Okay, and inside of this middleware, we have a new file. Okay, let's just copy this file from this middleware. What we need the async. We have a general middleware here. In the middleware, the async wrapper is general because we'll be using it both in the V1 and V2. So we leave it in the root middleware, and then the auth validator, you can use it in the V1 and V2. We leave it here. The error handler, we leave it here. Not found, we leave it here. Then the session auth and then task validator. We're going to be copying this. The task validator also will leave it here, but the session auth will copy it from here. Copy this. Because when we're implementing these tasks, move, no, I don't want to delete it. Copy. Copy. Let's just Command C. Command C, and then we move it to the middleware here. We paste for the Command V, like so. And then we remove this custom error API, and then we import it to match the path. Okay, so this is sweet in our session auth. Okay, so now let's go ahead in our route. No, not here. Let's cut it from here and then bring it here. Best. Okay, so let's do away with this. I don't know if it's correct, and then import it again, like so. So now our V1 is actually complete. So let's go to our auth controllers, async database, custom error API. These are coming from, okay, this is correct here. And let's check our task if it's correct. Database async wrappers, blah, blah, blah. That is correct actually. Let's check our middleware. Okay, our middleware is correct. Then let's check our routes, our auths. Okay, so in here we have a bunch of things to import. Import this one as well. Import this one. Register controllers auth, and in our controllers here. Controllers auth. Okay, that's correct. And then here as well, import this one. Import this one, validate, and then log in. This should be from our controllers auth, like here. And then session auth, middleware session auth, yes. And then the main route is from controllers auth, and then logout also from controllers auth. And I think, let's see here. Login the controllers auth, session auth, controllers. Okay, this is sweet. I think everything is the way it's supposed to be. Okay, so now in our task, we'll go ahead and do this as well. Token auth. No, we're no longer using the token auth. Remove this. Then session auth from middleware session auth. Yes. And then here, middleware task validator. Yes. From the root middleware. And then validate task from the root middleware as well. And this one also is coming from the root middleware, no, the controller's task. And then token auth, this is to be session auth. And then this from the root middleware. And then the next validate task from the root validate. Okay, we've already imported that one. Then get task from the controller's task. And then this is the session auth session, like so. And this one from the root middleware. Validate task. We've already imported that one. Then create task, controllers task. Okay. And then edit task, controllers task. Another edit task, delete task, controllers task. I think this is correct, the way it's supposed to be. Okay, so now I think I should close all of this, close all. And then we'll come back to our V1 is complete. And then we have our V2. So this V2, I'm leaving it to you. You can go and practice it. Try to clone this repo and then switch to this branch. And then try to move only the token authentication to this V2. Because both the task and the session auth are version 1 of our APIs. So try to copy this token authentication to this V2 because this is the version 2 of our own API. So coming down to this index, wow, this is actually good. Coming down to this index, what we want to do is space. It is an empty line. They want to use our authentication, but our session auth this time around, let's do away with our session auth like this. Remove that. And then our task, remove that as well. And then come down here. And then we'll do away with this. Then we'll prefix our route with /API/v2 /API/v2/authentication. And then here, this one is, we're not going to be using this, but we'll just say /API/ this is V1, sorry, V1, version 1 of our authentication. This is V2/auth. And then this down here is /API/v1/tasks. And this is cool. And then let's try to import our task. No, control, okay. Task is already imported, no. Okay, let's grab this from somewhere. Let's say we want to grab this import task from, let's go out, /API/v1/controllers/task, no, not controllers, route/task.js. And then let's move this up. And then our session auth will be the same. We'll bring in import session auth from that's API/v1/route/auth.js, like so. Okay, so I think this should work now. Or if in case we get a kabli, we will recheck our structure. Okay, so npm run our development server. Okay, I'm outside. cd express task manager. Okay, I'm inside of our express task manager, then npm run our development server. App crashed, so what's the reason? Cannot find module auth validator imported from the express task manager API v1 route auth.js v1 routes.js. Let's cannot find module auth validator. Okay, auth validator JS. I think we're going to be getting a lot of these errors because we did not postfix this with a JS extensions. I think that's all for that one. Let's check this one as well. JS. Which one again? JS and JS. Okay, we're done with the routes. So let's check out the middleware. JS, controllers, auth. Whoa. JS, and JS. And then we have our task, JS, another JS. Okay, let's now see what's, okay, another token auth is not defined in the patch route task, v1 route task. Okay, it's not token auth, but session auth. I think we did not change that here. Session auth, and then session auth, like so. Okay. Our server, another Cabli? No Cabli. And then it's actually running. Okay, so let's close all of this. Close all. Okay, so then let's open up PostMan. PostMan, you're going to be posting things for us. Okay, so now let's create a request of say HTTP /localhost 3000 / API /v1 /auth. And then this is actually a post request. And then in the body of raw, and then the format is JSON. And then we have an object of username. Let's see, Christopher, and then password of SES UGS Christopher says. Then I think that's all we need to do. Yes. Then let's send this request. Route does not exist. Okay, API /v1 /auth. Is there any mistake? App that use API /v1 /auth. And it's saying route does not exist. Session auth. Where's the session auth coming from? From the API v1 route auth.js. So let's check there also. Not here. v1 route auth.js. Okay, it does not exist because we have to first we have to add a register here. Register. Okay, so now we send our request again. And this time around, we expect something positive, not some kind of, okay. And then we have registration successful, and then errors no. Wow. This is sweet. So it's actually working. So what we want to do next is, what if we send something, we want to use our version 1 API, and we want users to, we don't want them to prefix this with v1 or all of that. We want them to send their, actually send their API version in this, their request. We want them to send their API version in their request so we can redirect them. So if you want users to send their API, actually you can leave this thing like this. in our index.js, you can leave it like this and then do it like and then if you want them to use, you can just, in your documentation, you say something like, if you want to use the version 1, do v1 alt, and then if you want to use version 2, put your v2 alt and all of that. Okay, but then we don't want that. We simply want to detect their versions in their request and then redirect them to where they want to go. So first of all, before we write a middleware for this, we write the middleware here. I don't want to write it at the top. I want us to be clear. We write a function, and then we say check out. Okay, check out version like this, and then it will take a function. Or should it take a function? No, it will take not a function, a version. It will take a version, and then what we do, it will return a function. And then inside of this function, it will call request, response, and then the next. And then inside of this body, it will check. But before we go ahead, we need to, that's the semantic version. We have to install Semver, npmi semantic version like this. Should take a couple of seconds. Okay, and we're done. So let's start our server npm run dev. Then we'll come back here. And then we'll say, if let's import our semantic versioning at the top. At the very, very top, I think it should be after the red limit session, like here. Import Semver from Semver like this. And then we say, if we want the semantic version to check dot greater than or equal to, and then we'll take our, should we take our request, and then it will, the request will be, the user will send the request there with the API version inside of it. Let's say X API version, like so. I want to check if it is greater than or equal to the version we pass in as an argument. Let's say if we pass in the version of 2, we want to check if it is greater than or equal to 2, the version 2, then what we want to do is, if this returns true, if we pass in an XPI version of 2.0 and we specify 2.0 here, we evaluate to true. And if it evaluates to true, say return next. But what if it evaluates to false? Then we say return next route. So most of you say, hey, I have a question, I won't allow you to ask. Let me just answer you before you even ask. Okay, so what's actually going on here is, if this version matches with the one we specify, we pass in as an argument, then this will pass execution to the next route. And if we bring in our check out version here, and then we specify 1.0.0, and then a user sends in a request with the version of 1.1.0, this will evaluate to true, and then this will pass execution to this session out, and then the session out will handle the request. But if it's evaluated to true, this will pass this to the next route, and not to the next control, not to the next middleware, to the next route. Here is a middleware, and here is a route entirely, which is an application level middleware. So here, this will pass execution to the next middleware, but if it's evaluated to false, it will pass execution to the next route, which is this token out. That matches, the token out has a post request with a username and then a password. So it will check, is it the same thing as this, but uses version 2? Okay, let's pass execution to this one. So it can handle it because this version is not the correct version. And then we copy this check out version and then paste it in here. Paste it in here as well. But then this time around, we want to change this to 2.0 like this, because this is a major change and it will break, because this is token authentication, this is session auth. So our API authentication version 1, then authentication version 2, and this is sweet. Okay, you are saying if we added v1 in our route, and then why are we still checking this? What if we don't have v1? Let's remove this v1 here, and then remove this v2 here, because some people structure their APIs like this. But the reason why we're adding v1 and v2 is for identification purpose. Maybe we have a lot of APIs and then we want to easily identify them. And we want the users to also know that, yes, if I'm using this, I have to do this correctly. But in this case, we can still do this. This can still work. Okay, let me show you something now. Let's just work with a random usernames and then a random password for now. Then I will show you how this is done later. Random username, like so. And then random password, so that we don't have to manually specify the password and then the username. Random password. Okay, so this time around, let's remove this v1. It's API/auth register. And then let's come to headers. And then we have some headers here. We have a cookie. Then when we logged in, our cookie name is KCTM session. And then our header automatically contains a cookie. And if we send a subsequent request, we are sending along with this cookie. That's sweet. And then the content type is application JSON. And then accept, this specifies that this telling the server that, hey, Postman can accept any kind of method, either text/plain, images, application plain, text HTML, text CSS, any form of data at all, Postman can accept. This is user agent, Postman runtime, and then the host. Those connection keep this connection alive, so that when next Postman make a request to our server, so no, this is Postman coming in, so we don't need to do some thorough check. Let's just allow Postman to, and all of that. So in this time, I want to add another header of X API. And you can see this is autocomplete API key. But now we are not using any API key, but we are specifying API version. I want to specify API version of 1.0.0. So right now, as you can see, let's check back and see something. See this. These are identical. So if we send this without specifying the version here, it will result to a conflict, because this is the same route as this. And this route has a register handler controller. This route also has a register controller. So if we don't specify the API version, then this will cause conflict. But now that we have our API version, then let's try this out. API version of 1.0.0. So let's send our request. Route does not exist. Okay. Route does not exist. API out. Check out version. Send validity request. API version. So why are we getting route does not exist? /API/auth/register. Send it once more. Okay, I think. Okay, let's comment this out and see if we're the people costing. I am. If I'm the person making the mistake, internet server error. Okay, comment that out and do this one. Internet server error. Okay, return next, route, next API version. Okay. So what's the problem here? API version of 1.0.0, application JC, PostMan message internet server error, API out register. Okay, it does. Okay, so I don't really know what's wrong. All we had was we had a V1. So let's try this again, and then let's add back the V1. V1. So we don't want to save this right now, and then send the request. Okay, the body, internet server error. Request XCPA version, the version here. Let me move this here. And V2 / auth. And then here we'll log version, and then log okay. One 1.0, 2.0, 1.0, yes. I think the problem should be where I'm using random, the body, random username, and then random password. This is some SES 185. Let's add a numeric. Let's make it alphanumeric, and then let's make the password SES and then send this request once more. I'm still getting wow. Okay, let me delete this. Send this request. What exactly is the problem, and why am I getting this error? Let's log the XAPI version. Log request XAPI version, like so. And then let's come back here. API v2 auth, API v1 auth. Then here in the postman, the body, headers, X API version. Then we'll make it 1.0.0. Then send the request. And let's see what we've got here. We're not getting anything, or are we getting something? Let's start it again. Well, it means the request is actually not going through. Let's comment this out. I think that is the way where the error is coming from. It's still the same thing. Okay, so let's remove this one. And then send the request once more. You register successful with an XX API version of 1. Okay, so the check out version. Oops, no, check out version is a problem. It's problem here, problem here. So version of 1.1.0. If the version is greater than or equal to XAPI version like this, I want to do this. Let's do it once more. Internal server error. So this, the problem is from this function. And let's examine this function. Return the request, the response, and the next. And then we use Semver to compare the request API version and the version we passed in. And if the version is greater than or equal to the version we passed in, then we want to pass context to the next middleware, which is the session out. And if it is not, we want to proceed to the next. Okay, so here is a great mistake I think I'm making. The request headers, which, as you can see from here, we're sending this in the request headers. Oh, this is a minor mistake, but it will cost you a lot. Request headers. Request headers. Request headers. It should be in our request headers like this. This is the request headers because we are sending it in our request headers. So let's uncomment this and then come to our PostMan and then change this to a random. Okay, let's change this to 2 first and then send our request once more. And okay, it's working now. And then instead of, let's change it to a random username. Then a random password so that we don't have to come here and then like this. Okay, so now our API version is working, but then if you try to use the version 2, it will not work because you've not done this. And all of this here, this route, you remove this route after moving your version 2 to the V2 folder. You remove the route, you remove the controllers, and then you leave the middleware because there are some middleware, the async wrapper, the auth validator, and the rest. We're using them both in the V1 and the V2, so you leave them in the root directory like that. And the errors folder will be there, but you remove the controllers and you remove the route. and then you delete some middleware in here. And then if you want to access, and you come to your API, your V1, and then inside your V1, you have your auth and your task, both the auth and task. And then your V2, if you want to modify other things in your task, you can equally have your task.js. And then in here, you can have your auth.js, that is authentication, like this. So if you want to use the V2, and then because there will be documentation for all of those things. So luckily, our this thing is working. And then what I wanted to show you, I did not show you again because of the error we had. I wanted to actually remove this V1 and then say /auth and then save this file. Let's come back to Postman and then remove this V1. This is API /auth. And then send this request again. Let's see what we've got. We've got a registration successful. So in a case where the URL is not, there's no V1 in our domain, in our URL. So how do you identify, how do you know that, oh, this is version 1 and this is version 2? The only way you can know that is to use your API key. And then in our document, we'll be learning how to document very soon, and then we'll learn how to use API keys and all of that. Okay, so let's come back here and then say v1/auth, like that. Okay, that is our versioning. In review, we've learned how to version our APIs, move our v1 version 1 to here, API version 1. And if you don't want to do so, there's another way of doing this. In our own structure, it's a very different way, because we have it's a minimal app. So we have the authentication controllers and the task controllers in one folder. So, but if you don't want to do that, in your API, you can have something like a task folder and then the authentication folder. I think this is more structured. And in your task, you have your folder of V1, and then you have another folder for task of V2. And in your authentication, you have folder of V1, and then another folder of V2. If your application is a large-scale application, this is how to structure it. In your API, you have your authentication, you have your task, and you can even have another of products and the users and all of that. So here you have your V1 and V2 and V3, V4, V5, depending on how regular you release and you change your APIs. And then the task, we have V1, V2, V3, and all of that. So this is for educational purposes. Then in our case, we have API version 1. Then inside of version 1, we have the task controllers middle, and then we have our task authentication, because it's a minimal app. But if your app is a very large one, if you are building an app that will go into production, meaning any app that's going to production will have to be used for a very long period of time. So you have to structure it like this. I'm going to leave it so that you can check it out for reference purpose like that. Okay, that's sweet. Let's come back here to our lists and then using meaningful URLs. Use meaningful URLs. We're not going to talk about this because I've told you why these meaningful URLs are very, very important. API/v1/auth. When you postfix it with your domain name, it becomes your domain name /API, and it's very, very helpful. This V1, this V2, and then even the developers and the user, it's bring about a great developer experience and a great user experience, and that's sweet. Okay. And the next on the list is handle errors and status codes. We don't need to talk about this because we'll be handling errors and then status codes and all of that. If we move to our controllers and then we move to our task.js, we can see that we have REST status code, so, and all of that. And if there's no task, no error is no, but if there's no error, task, all of that, we find out status code, and so that the client will know that the status code, if the status code is 200, we want to do something like this. If it's 201, we have to do something like this, and all of that. Okay, so all those are part of a good API, and then we learn to design our API using all of those methods. The request and response formats. The request and response formats, we've got them here. The requests, the format of our request is coming in like this, and then the response of our request, we have to generalize it. If we have a task, we don't have errors. But if we have errors, we don't have a task, and then we have to make it uniform, like that and like that and like so. You can even build on top of that and make yours more generic and more unmaintainable, and then add more sugar to it. The authentication and security. We've added authentication and security to our app. And in here, if you come to API, you come to view one, controllers, and then task.js. You will notice that here we've got, we want to fetch all the tasks, but we want to fetch where there's a user ID, where the user sending the request. The task is associated with his or her ID. It's associated with their ID. So this is, and if you're not authenticated, then we send you a message of not authorized, and then all of that. So we make sure everything is secured and then very sweet and complete. So in here we have pagination, sorting, and filtering. Okay, we started to talk about pagination and sorting and filtering when we built our task manager initially, but then we skipped. And then I told you that we'll be talking about that later on, and that later on is today. Okay, so let's close everything here and then see how we can do that. It's very, very important, because in a case where you have about 100 tasks and you want to display 10 at a time, 10 per page, and you don't want your application to overwork, like to overfetch, and then waste a lot of time and then display everything at once. You just want to fetch 10 per page now, and we are going to implement this. We want our application to fetch 10 tasks per page. Okay, so now where do we do this? We do this in our v1 controllers task. Okay, let's come up here, get tasks, and all those are queries. The page, we got our query, our completed, and all of that, but we're going to be changing this now. We change this to, let's say we're getting our filter. Page. Okay, let's start with page filter, and what else? And then we're getting our sort, because we want to sort either in ascending or descending order. But our page has to be a number. So what we say is we say let page, like so. And then okay, let's say let's change it to page number, like so. And then you say page, and then you default it to page page number. Is this how, as, or is it okay? Actually forgetting this. How okay, page number. You don't have to remove this page number. And then you see page is equal to parse int page number. We already have, okay, let's see, what am I even doing? Const page number is equal to parse int page, like so, our page, and then we remove this, and we change this to a small u, page number. Okay, we've gotten our page, and then our page is a number, or we default it to 1. If there's no page number, if it's not undefined, then we default it to 1. So we first of all build our query in such a way that if any of this is true, then our query should be executed. So we build a query object. First of all, we build a query object. Then we say say above this, we say here we say const query is equal to an object literal, and this object will take a skip, and then a skip, and then the next item should be the take, which is okay, this, let's change this to even a page size. We want the page size to be 10, the item to be 10, like so, and then we say page size, like this. So we have an object literal here, and then we say if there is this here is actually incomplete. We have not defined our page size and our skip. Then we have a page size, this is a page number. We have a page size const page size of 10. We want 10 items per page. You see, we're getting our page. Let's say if the page is page 1, and on page 1, we want to have 10 items per page, and then page 2, we want to have 10 items, but not the previous ones, the next 10 items on our list, making it 20. But the previous 10, we will not display it, we'll display the next 10. So our page size is 10, and then we have a skip const skip is equal to page number minus 1 times our page size, like that. Page size, like this. And what we are actually doing here is, if our page size is 1, then we have, sorry, if our page number is 1, we say 1 minus 1 is 0. 0 multiplied by 10 is 0. So we actually want to skip nothing. We want to display the first 10. That's why we're saying take the page size. We're taking 10 items. That is Prisma. We see how we use this. They want to skip none. But if our page size is page number is 2, that is page number 2. In the page number 2, we want to display the second 10 items, not the first. So we say 2 minus 1 is 1. Then 1 times page size, 1 times 10 is 10. So we skip 10. We skip the first 10 and display the second 10 on our list. And if our page list is 3, that means if we're displaying all, we have 30 items. But since we're displaying 10 items per page, we'll skip the first 20. That is 10 for the first page, 10 for the second page. And then we take the third 10, which is for the third page. Then we say 3 minus 1 is 2. 2 times 10 is 30. Sorry, 2 times 10 is 20. So we skip 20 and take the next 10. That if added to the previous 20, yeah, so skip is the offset. Yes, the offset. But in this case, not everybody understand what offset is. So let me just briefly, not briefly, but explain it in such a way everybody will understand. Okay, so now when our page size is 3, we want to display the third 10, the third 10 items. That will skip the first 10 for the first page, the second 10 for the second page, and then the third 10 for the third page. You see, the third page is page number 3. So we say 3 minus 1 is 2. 2 times 10 is actually 20. So we want to skip the first 20 items and then display the third 10 items on the list. And then we say 2 minus 1, we skip that, and then we want to skip that and then take 10 items. But we want to first of all skip the first 20 and then take the 10 after the 20 that we've skipped. So this is the query we've built here. So we'll see how we can use that. Okay, so now we've implemented our query. Then if there's a sort, that is actually our general query. If we have a sort, if the sort is specified, the sort here, what we want to say, we say query I assume we know how to work with object. If not, this will be a bit confusing. Query.ordered order by is equal to sort. We pass in our sort and then we see ascend. Order by, is it ascending or descending? And we actually pass this in also, but you can equally implement it. If it is toggled, then it will send in as a ascend or descend. Or what you can do is change this one to a generic name like title, and then change this one to something you can send in from the query that it can be ascending or descending, so that if you toggle it, it should be sorted in ascending order or descending order. But in this case, we're passing, and don't be confused about this. This sort here, let's assume we are passing in sort. Sort is equal to title. So if you pass in your sort, if the client side is passing in sort as title, this will be replaced here as this title. Sorry. What am I doing? Okay, this will be replaced here as title like this. And then Prisma will know that, oh, they are saying that this person specified that we should sort this title in ascending order. So that is the reason why we're doing something square brackets and then sort. This object, we identify this by its value and not the property. The value, not the property. Good. The same way we dealt, we did something with symbols. It will take the value and not the property. Thank you. And then in here, we remove this. If there's anything you don't understand, you can go ahead and ask, because this is very important. You need to understand it. If there's a sort, we want to add an ordered by a property in our object. That it's also an object literal that we have a sort with a key value, and the key will be the title of the key will be the value of the sort, and then the value will be in ascending order, like that. Okay, so what if you have our filter? What else then do we want to do with our filter? Okay, so if we have our filter, if there's a filter, that's if the filter does not evaluate to false, what we want to do is we want to add to our query object, query of where is also an object literal, which we want to say, or as we earlier did down here, but then we want to generalize our query, or then we say title, then another object contains filter, like so. Wow, this is sweet. But in our case, let's change this to title and then completed, like so. And then we come down here and then we'll say title contains title. And after this, we'll say completed. We'll say completed exactly equal to true. Then this should return true, else it should return false, because we don't want to do that JSON something. They should be like this. And then we want to take out, but before I take out this object in here, you can do something like, after where, you can say, can you say skip and select? Can you see the skip here and select? And then you can have take. Can you see the take? All are coming from this object. That is the reason why we have our skip and take in here. And this object is the object that will replace this general object here. And then the where is inside of this object. That's the reason why we added our where to this general object. And then order by. Can you see the order by? And order by, you have either an ascending order or descending order like this. Okay, so now we will take up this complete object like this, take out, and you can leave this like this if you just want to fetch everything or want to apply all this. Then we'll see what is the name of our object. The name of our object is we say where, no, not where, please. In our original object is where or, and then we have user ID like this. Our user ID, which is up here, and then the or. So we want to fetch that's by a specified user, the user that is logged in. We want to fetch only the user task. Then we have our query. The query is the general object. Then we come down here and then we see a query like so. Wow, this is sweet. Very, very sweet. And the reason why we're doing here that if it's completed is equal to true in string, then we want to return true or return false, is because this will come in as a string and not as a Boolean. And then we can convert this to a Boolean, do something like completed is equal to JSON pass completed. And this will be converted to a Boolean. And then we can say completed here. But I don't want to write this. I prefer doing this. Because if it comes in as true string, true in string, it should return true. But if it comes in as false, then it will return this false. So you can go ahead and play around with this. Now we have a very functional application with all of this, with a very standard query that we can sort this sort can come in as title. So let's remove the sort. And we just want to sort this with a title like this. So we want to sort our title in ascending order, and then you can pass in a sort by. You can pass in, let's take sort. Let's just take in the sort and then replace this with a sort like this. Okay. So now if you send in a value of ascending, this will be sorted in ascending order. If you send in a value of descending, the title will be sorted in a descending order. Okay, so now let's verify that everything is working. Now we'll create a new request, a post request. What API v1 / tasks / like this, and then the body a raw type of JSON, and then we have title. And what I want to do is to create title random job title, transport image, transparent type, MIME type, lorem text, database type. I think we should just use this job title like this. And then the description should be description of random lorem paragraph. Random lorem paragraph. Lorem ipsum. Is it lorem ipsum or what? Front-end developers understand that better. So let's check our headers. Right now it's not appearing, but let's send this request and see if we're logged in. Internet server error, API v1 tasks, API index, API v1 tasks, version 1. Okay, it's like I didn't specify the version in our headers. API, and this is an opportunity to validate something. Let me come. I think where the error is coming from is here. You see, if request headers XPI version, if it is null, then we throw a new custom API error of API version missing. Sorry, missing like so. And then is it a status code of status code that it's a bad request, I think. Bad request like this. Okay, so let's see if it, because we did not specify this thing. Let's send the request again. API version missing. Wow, that's great. Okay, now because we did not specify our API version. And then in here, we can say X API version. They will specify 1.0.0. That's the API version we want to use. Then we'll send the request. Are we unauthorized? So let's come back here and register. Send the request. Route does not exist. API v1/v1. Okay. I think you should be successful now. Why is it taking time? Okay. Registration successful. And then we'll come back to this place. Then if we send this request, we notice something. Okay. Now notice something up here. We have a cookie. It has been added automatically, and you cannot remove this manually. It is disabled. This checkbox is disabled. Cookie, KCTM session, this. And then if we want to make another request, this is the cookie we are using to make our subsequent request. So let's create like 5. We have orchestrator, then the Lorem Ipsum passage whatsoever, and then errors no, then the user ID this. Then let's send another request, create another task. Supervisor. These are not actually tasks. These are engineer, but we don't have random tasks. So I just want to use this for testing so we can understand very well. Then liaison. Then how many have we created so far? Analyst. Okay, I think we'll have to stop from here. And then from there, we'll create another request. Let's make this request. Let's copy this, paste it here. And this is actually a GET request. And we're already authenticated. So we don't need a body, we don't need anything. Let's first of all send it. API version missing. Okay, that's great. We don't specify the API version. And later on, we'll be learning how to use environmental variables. So all of this will be, you come here and say X API version of 1.0.0. And then we'll send it again. We have errors, invalid value. Invalid value, part completed. I think this should be coming from our task. And maybe we made a mistake. Controller's task, no, it should be in the route task, and then the get. Comment all of this out like this. Okay. Because we've changed some things and then we've not validated them. That's the reason why we're getting results. Okay, let's send again. The get request. This is actually a get request. API v1 tasks. Invalid value, path title. Wait. This is get, okay, ID. This is actually to get everything. It's here, let's comment that out. Let's send the request again. And we're getting an internet server error. So what's the problem again? Session of get tasks. And let's check our controllers. task controllers. Where user ID. ID, user ID, request user, and all of this. If there's a filter, okay. Let's take it out of here. And then we'll have to, okay, we have another problem here. Let's see. Let where equal to user ID like this. And then if we have a filter, and then query dot where is now equal to this. Okay, it should be, well, first of all, where like this. If there's a filter, we want to add our, this where we have here, we want to combine it with, we want to merge it with this object so that we have our user ID. But if there's no, what if there's no user ID? Then our query will have where okay, where, okay, like this. Let's make sure we're doing the right thing, the correct thing, because we want to fetch our task where there's a user ID. So let's come back and make a request. And if it fails, we do a thorough debugging. Okay, internet server error. And then let's actually remove this query here and make sure we're doing the right thing. Do something here like where it has an object of a user ID like this. Where user ID. Okay, let's fetch our tasks. Send a request. Okay, we still have an internet server error. So what exactly is happening? Tasks ID. Okay. Get task. So I say with database task, find many where user ID. Okay. So we don't know. This is the one we have here. We have 3AR11. 3AR11 cookie 1. We have one cookie. Yes. The path is the home directory. It expire on Tuesday, 3rd October. Today, actually, the time 12:01. Secure is not secured because we're in development. And then the headers. And why is it? Okay, let's check our routes with the task. Session out, then get tasks. This is correct. Then the task controllers. Find menu. Okay, inside this find menu, let's remove this and then see if it's actually the cause of a problem. Send a request. Internet server error again. Oh, request query. Okay, let's come back here. Comment all of this out. Task find many, task yours, no. But we need a user ID to fetch tasks. User ID. Okay. Let's send this request once more. Okay, so we have all of our tasks here. Okay, so now we're going to be following this bit by bit now. Let's first of all comment this out. Let's totally remove this. So we have request query, we have a title, page completed, page size. Okay, so let's send the request again. Make sure it's working. We'll be doing it step by step. Let's return all of that. Okay. Okay, correct. Okay, so right now we want to say where user ID. We'll say ordered by. Okay. Title. That is where the mistake came from. Title ascending. Okay, let's say title sort. Sort. And then we also have take page size. And then we have our skip. What are we skipping? Skip page number, right? Yes, we'll skip page number. No, we'll skip. Okay, we'll skip like this. This is the skip. So let's just put it in like that. And then we'll have what else? What else? Ordered by take, skip, take, where? Then sort. We have our sort here. The title completed. Okay, let's now implement our or. No, no, no. Or like this. Title includes. Okay. Now we'll send in the page and the sort so we can see what we got. So first of all, what we are getting here, we're getting the title of OS and the way we created them. So first of all, let's come to our params. And in our params, we say sort is ascending. And then what else do we need to send? We'll send our page. Send page. Okay, let's send two so that we'll know it's properly working properly. Page. We'll send 2 items per page. Okay, let's now send our request. Unauthorized. So that is the disadvantage of using a random. Okay, here we'll have to do this again. And that user with his or her things is gone. So we need to create, okay, create one more. Supervisor, specialist, producer, and then developer. Okay, so now let's come back to our so let's send this request. Tasks, no. Okay, page 2, and I sent in page code 2. Let's remove this. Internet server error. Okay, remove this and send again. I'm still getting an internet server error. So what did I not send here? Page number, this, that's where ordered by site title sort. Let's remove this, save this, take page size and then skip this. Send the request again. Internet server error, page. One, two, three. This we have 1, 2, 3, and 4. Okay, so it's not working as expected. Page number 1, where is I take page size, which is 10. Okay, let's say we want to take 2. We want to take 2 and send the request again. Okay, so it's now working. For the page, we have 2, 1, 2. That is the supervisor and the specialist. So let's put these are 2 here. For the page 2, we take producer and then the developer. Okay, that's great. So this is actually the pagination is working, but then the sort ordered by title. Okay, let's do this like this. Ordered by title sort. Okay, send the request. We have producer, we have developer. So let's see something. Specialist, supervisor, specialist, and supervisor. Okay, let's take out this. And then come down to our code base and then see here 4. And send the request again. Internet server error. Page 1. Send, you did not send the page along. Okay, so now we are sorting it. We have DP, after P we have S and S. Okay, so now it's working. So let's remove this and then put in the sort that's coming in from the request query. The sort here we have ascending. Send the request once more. Yes, we still have our developer producer, and then let's change this to descending. Send it again. And this time around, we have supervisor, specialist, producer, and then developer in descending order. Okay. Hopefully we've implemented our pagination and then our sorting. Then we're left with and then let's call it a day, so that in our next class we add our filtering, and then we restructure this to only accept the values that are being passed in by a user. If the user passes in a page size or all of that. Okay, so if you have any questions, you can go ahead and ask. And in review, we've versioned our API, and then we're trying to add filtering. We've added sorting, pagination, and then we're trying to add filtering to our API. So if you have any questions, you can go ahead and then ask before we call it a day. Any questions, please? Okay. In absence of any questions, we'll call it a day, and we all meet again in our next class. Thank you.